So this presentation is for nerds. So if you're not a nerd, you can go get a coffee, drink. No, seriously. No. No, because, during the Arduino day, there needs to be some space for the Arduino nerds. So, but apart from the jokes, the idea is to explore a little bit some of the work that Arduino does as an open source. Oh, thank you very much. Overly qualified assistants in this company. So this is actually vodka, but posing as water. But now so the general idea is Arduino does a lot of work with open source, and actually we release a ton of open source code, and not everybody understands the amount of work that we do also on some very significant piece of code. So we actually sometimes spend a long time crafting bits of code that actually, in my opinion, contribute quite a lot to the community. And sometimes that part, people are used to using the classic Arduino, they don't understand. So this is going to be a bit about that. So if you look at our GitHub repository, there are hundreds of public repositories that you can access and get code from. And the idea is that we cook all this source code and we serve it. And we have a lot of internal developers, but you also have, lucky enough, that there's a large community of people around the world that help us as well. So let's touch some of the stuff, some of the code that I'm talking about. So I think one of the most interesting example is this Java IDE, which is what a lot of the people used to program their Arduino, but actually in the last few years we have done quite a lot of work to open up the IDE so that you can actually install software that you can use for boards that are not official Arduino products, but products made by other people. And we are very happy that we can participate in this ecosystem and help other people take advantage. Also because I don't think it makes any sense for us to be doing the same thing multiple times. So we're trying to be even more open. So if there are ways that we can be more open, please let us know. But so last night, our fantastic team, Christian, Maglie, Martino, and all the other team released the new version of the IDE, which is a number of interesting features. Some of the features were so esoteric that when I read, okay, when was that thing? Like the one about the compilation, the definition was incredibly fancy. Now, there were some words that I didn't know what they meant, so it must have been a very serious type of piece of code. So, but the general idea is that, as I mentioned, there was 30 million downloads only last year. So you have to imagine that 30 million means that the community of people that are actively, the vodka, is that are actively using, if you are somebody who moves his hands a lot and then you have water, it's not a good idea. So I'll put it here so I can kick it later by accident. And so the general idea is that this has become a tool that a lot of people use, even with products that are not Arduino products. And this is when I talk about being part of a big ecosystem and leaving room for a bunch of different groups, companies, enthusiasts, open source groups to kind of work together on the same tools. And it has almost 9,000 stars on GitHub. This is a very nerdy measurement, but it means that there's a lot of high-level kind of nerds who like the code that we wrote, and this is based on the processing project, which is a tool that we love and gave a lot of inspiration to Arduino. So this is a nerdy statistics. We will publish the numbers. So basically, when you install a library in Arduino, and libraries are very important. They're a huge ecosystem. People write Arduino libraries to interface sensors, interface protocols, add feature to the language, and they are very, very important. So for example, our IDE has 2,000, more than 2,000 available from inside the IDE, but we made an estimation that if you look at all the different types of bits of code that are available for Arduino, there's kind of more than 7,000 in the wild. Some people have been asking lately, which ones are the ones that people download the most? This is not necessarily an indication of how much they are used, but at least it's how they are downloaded. This is something that we asked ourselves a lot. We wanted to do this in a way that didn't infringe on anybody's privacy. So, Luke and the team did a lot of work to basically extract the information, keep the privacy of users as much as possible, because we don't want to we don't want to profile anybody. We don't want to know what you eat for breakfast. We just want to, work together on Arduino, and that's it. So there are some interesting. You realize there's a lot of different bits of code that people use to interface with different things, like to build infrared remotes, or for example, Firmata is very popular. This is for LCD graphs. There's some other Adafruit. Adafruit has a lot of libraries they write that help people a lot. So there's a lot of their libraries in here. So I will publish this number later on in the next few days so that people can start having a look. But I think it's interesting to see the diversity of projects that people do using all these different libraries. And so these numbers are from the beginning of January. So we started tracking this information only from now. So the other thing that is quite interesting is that you can actually run Arduino on a bunch of different hardware. So the ones in blue on the left, these are the ones that we write or maintain. So one of the things that maybe a lot of people don't realize is that you can actually write Arduino code and run it on Linux as an application. You can do it on Intel and ARM. So this is something that you can actually do now. It's available for free. And I think it makes, in a way, if you have skills in Arduino and you have, for example, a Raspberry Pi or a BeagleBone or even a big Intel Edge machine, you can program it with Arduino, so you can transfer your Arduino skills. And a bunch of companies around the world, including, this is Sony, this is Microsoft, this is STM, I don't want to, this is Realtek, that's STM. So a bunch of different companies have ported Arduino to their platform. So this allows people to take a piece of Arduino code, and by changing just a few lines of code, running on a different piece of hardware. So the part in yellow is the work of the community. And I've only stopped because I've kind of ran out of screen space, but there's a lot more. There's a lot more. So one of the things that also I want to highlight is the fact that in order to make the software development more open to people, we develop a bunch of different modules that allow people to use what our development environment does in their own environment, in their own software, in their own services. So for example, these tools here, the preprocessor, the builder, and the command line interface, these are projects that we built in the last 2-3 years. They basically break out the intelligence that is embedded in the Arduino development environment into tools that you can embed in your own projects. And actually, some people are using it already in their own, in alternative development environments for Arduino. So all these are names of GitHub repositories, so you can go to GitHub and find them. There is a lot of work in those pieces of code, because when you press the button and you want to compile a piece of Arduino code, since we want the code to be very simple to users, the development environment, the IDE, has to make a lot of work to understand how to turn that into a piece of valid C++ code. So there's a lot of intelligence that goes on in this module to make that happen. The same thing happens with the online IDE. We created a bunch of modules that are used in our online IDE that you can actually use in your own projects. So I advise you to go out and check. But for example, this software is the one that allows, when you're using the online IDE, Create, which runs inside the browser. In order for that to talk to your hardware, this piece of code makes that happen on any type of operating system. Or these are things that we use when we want to manage Linux machines remotely. So these are all bits of code that we make available that people are using or you can use in your own projects. So this is the peak of nerdiness in this presentation, because I'm trying to highlight the fact that we just released this IoT platform that allows people to build Internet of Things applications that are secure from the get-go. So they are born secure. And to do that, we had to develop a bunch of different code. This is, the number of people internally who worked on this is too long to mention. But the idea is that we built different libraries to manage the power inside the processor, so you can make it easy to run your hardware on batteries. This is very important. All of our new boards have this encryption chip on board that make it very secure for the hardware to connect to the cloud. So this allows people to build secure projects from the start, so without adding security afterwards. Unfortunately, a lot of tutorials, code platforms that you find online, they basically say, well, let's build this thing, and then later on, let's figure out the security, which is the wrong approach. So we're trying to say, let's start from a secure approach. And so we use a hardware chip to do that. And then we even had to take and build our own SSL stack to do the encryption, to be able to take advantage of that chip. And we built a bunch of modules. And also, on your browser, when you want to communicate with the device, we developed another module that makes it easy to create a communication between the device and the browser. So the general idea is there's a bunch of code that powers our cloud. But if you take these bricks, imagine them as some kind of a Lego brick, and you put them together, you can actually very quickly build your own secure IoT solution, even without using our, my CEO will, no, but it's important. Now, you can build it yourself using these modules that we give to people. So you can use an MQTT server here and build your own thing. So, and this is very important for me, that the underlying protocols are open, documented, open source, that anybody can use them, because the more people use this, it impacts and benefits all of us. One little mention, this module here called Arduino Core API is something that in the presentation I made in the last few years I called the chainsaw project. And this allows the people who port Arduino on different processors to have a starting point which contains probably, 40% of the code already there, so that we don't have to waste time all doing the same thing, because imagine all the people in this slide are all doing the same thing. They're basically replicating those 40% of code. So if we all use that little thing here, we can save 40% of the work, get a better code, and work together more. So we are trying to build more and more of these tools. And also, all of these IoT products that we keep talking about, they're all open source. If you go to our website, you can download the files, you can go make them yourself, you can, we think you should buy them from us, but, we want to foster innovation and enable people by providing all of the files for this. And each one of these contains a piece of code, which, again, seems like a little, it's got a very short 6-letter name, but there is a ton of work and sweat and swear words as well in the Vero Christian, in the project, and also Violant, yes, in the project, because each one of these enable you to use these very powerful modules. But again, if you have your own hardware, which is using a uBlocks, Sarah, or Nina hardware, you can use our code and build your own solution. So again, we're making this tool available for people, and hopefully we can work together to make them better. And I'm not even touching the amount of work that the team is doing on the FPGA stuff because it's, again, way too complicated for me to understand, but there's a lot of stuff there. So yeah, what I'm trying to say here is that we make all this available. A lot of people don't understand that all this stuff is available. They see Arduino kind of, as the classic kind of Arduino, but there is a ton of work there that we make available because we want people to use it. We want people to work with us on it. So to highlight the importance of open source for Arduino, I have a small announcement that I'm very proud, let's say, proud about, which in open source, you have to help each other. So on our packaging, you can see that we say open source is love, no? So open source is love, because in the moment you take hours and hours of your work and you make it available for free to anybody, that's love. You love other people, you want them to work with you, no? So there's an element of love. Although it's nerdy love, it's still love for other human beings. And but a lot of open source projects, they basically don't have a business model that allows them to get money to support themselves. And I think it's very important for the projects that have a way to make money by selling hardware, for example, that we help each other. In the past, we've done it already, then we had to pause for a number of reasons that are too long to explain. But basically, we have decided that starting from this year, we're going to be donating $50,000 to the open source projects that we benefit from. So we're going to do this. There's going to be a detailed blog post coming out very soon. But the general idea is that we're going to be selecting a number of projects because they're clearly benefiting us, and we take their work and we want to give money back to them. So roughly half of these $50,000 will go to open source projects and the entities that support them, say Free Software Foundation, for example. And the other half, we're going to be asking the community to tell us which projects, which open source projects they think we should be supporting. And I think, I think it's very important because, again, open source works if we all work together, if we all help each other, but it also works if you try to give back. We give back sometimes by fixing code, fixing bugs, and all of that, but we wanted to do more. I'm very happy that we were able to do this, and I think it's, for me, it's a very nice way to end this presentation. And I hope that more and more people follow our example, because otherwise we are so reliant on open source software and hardware in our lives, but sometimes we don't realize because there's so many. Have you seen all these little blocks? In some open source projects that you're using, if you have an Android phone, there's a lot of Linux in it. There's hundreds of people that develop Linux. There's a lot of different modules. And so we have to support each other, either by doing work or also by donating money, and we're starting. Thank you very much.